Hello friends, welcome to our YouTube channel, and in this video we're going to see how we can draw our borehole data, that is the soil profile data using GeoStudio. Okay, so I have got hold of this GeoStudio 2023. You can just register as a student person and use it for non-commercial purposes. Okay, so let's go ahead and see. Here we have a borehole data. If you just Google, you can find it. I think it's UTS data. So you can find it. State University. This is from one of the assignments. Okay. So here, as you see, this is the site plan, and we have borehole one, borehole two, and borehole three. So borehole log for each is given, and if you don't know how to read the borehole log, it's very easy actually. They just have similar, uh, you know, format across the world for this particular. So here at the top, you can see the client's name. This is the job, location, and log by who logged it, and the date is very important also, and the whole number is also important while plotting, and that will reflect here so that you exactly know where the portal is. And the seat is, sometimes it's long, so there may be multiple seats. Okay, so this one is small, like the day it's not very deep, so it's just one seat. And then the surface level RL and the rig, the rig that's used for the for this taking the sample. So details is vertical hole and flight over. What kind of over it's used. This is just information about equipment. Okay. And here starts the main thing. So first you have this method. Which one? What is the method? So auger bit method. This is used for the taking the sample for this particular boring the hole. Okay. Then this is sample. You know, and then the D1 sample, and then this is tests tests performed, and that at these depth, for the certain depth, the SPT test has been performed, and how many blows from which level to that level, number of blows that took. So this one here, the SPT, you have this value, and this is a fix like it's 450 mm, and these value indicates 678. You must be familiar with SPTV, that is the standard penetration test. And for each 150 mm of penetration, the number of blows required is recorded. The first, you see the six, that's a seating blow for, seating drive for that particular first 150 mm um, blows, 150 mm to drive the blow. Six blows required for 150 mm to drive, and it is the sitting drive. Then the next 300 mm depth has to be driven, and for each 150, this is 7 and 7. Similarly, others are there. And if this particular value, the next 300 mm depth, the number of blows required is known as standard penetration resistance, or otherwise you can call it n value. Okay, and if that n value exceeds 50, then it is normally collateral fusion. Okay, so that means it's a good. Generally, this SVT method is seen as a very economic method for geotechnical investigation, and a very popular method for the investigation as well. So this one is the test, and then water. And where is the water? Where do you get the water? Here you have the level, and then there is depth, and this is right now meter. Okay, we are following the SI units in meter, and this is the scale. So each of these between 0 and 1 is 1 meter, and there is a half, midway is half. And then after that, there is a log. Okay, and there is UCS. So UCS, first let's understand UCS. USCS is Universal Classification. for the soil. Okay, so as per the universal classification, you must be familiar in the soil mechanics. You must have studied this. So these are the names, okay, given in USCS. Okay, and at each location, as the auger, drills from the top from zero level, as it drills down, these kind of the soils, these are the classification of soil that it is encountering at each level, and this also represents how thick is that particular layer of that soil. Okay, and these has to be plotted so for some kind of visualization. So you can even plot this in Civil 3D as well. I will show you in maybe one of the future videos how to plot that, and this is very important for the visualization process. And right now it's in straight line, and we assume the soil to be, like we assume that soil to be homogeneous around this particular part, aligned with these three values. Maybe here also it may be same. This is what our assumption is. Normally, so in the periphery it remains the same around certain pockets. So you see, first borehole is here, BS1. Second one is BS2, and the distance between the first and the second borehole is 22 meter. Yeah, and then the borehole 2, and then there is borehole 3, and distance between. Okay, and the distances you have to find there. This is the data we need to plot the soil profile, and this is the another data, the depth that we will need to plot. And here we have the description for the material, what this the code means um, in USDS. And after that, we have moisture content, and here is a remark with moisture content, and then consistency value here, and then there's a remark that observe and other relevant data. So hole stood without supporting after drilling, so it did not collapse. It's just indicating that it's a bit stable. Okay. So let's see how we can plot it. Okay, so first data that we have to extract is for BS1. Okay, so here you see the BS1 here, and we have different type of the soil. So just write down what type of soil you have. The first one is SP, another one is also SP. Okay, but it's different. You see, this is sandy loam, this is sand. Okay, sand gray at first. This one is different, and even this one is different, but these two are being indicated, just a slight difference is there, and being indicated are the same, so we can put it in the same. Okay, so this is sandy loam sand, this one is silty sand. Okay, and we can call it clay sand here, and then it's the sandstone. Okay, at this point, so first you see this one is exactly almost exactly like zero point 0.5. So this particular layer will be zero point 0.5. Okay, and then after that, this layer is almost 1 meter from zero point 0.5 to 1.5. So we just have to note it. Okay, note it down. Then we will create some points, and then first we have to be familiar how we sketch on the GeoStudio. So let's go ahead and see the GeoStudio first. So this is what you get at the when you open the GeoStudio, and I will just start with 2D. Okay, 2D template, and then so that's 2D, and then with the slope slash W, just for slope analysis. Just keep it okay. Then here you have you can choose, but right now we are not doing any kind of performing any kind of analysis, so I'll just keep everything as it is. Okay, fine. Now first thing that we will do is define the axis. Okay, so you see here, uh, from here to the zero, and down it goes to depth. Okay, this stuff. So it's better. we do it like that. So we go first here at the top. Here you see there is X and Y plotted, something like that, and then there is a pen. So this is sketch axis. When you hover over it, you can see sketch axis. So I will say sketch axis, okay, and then uh, there will be elevation and distance. So the basic idea is for elevation, for one particular borehole, elevation will be like this, and then from one borehole, there's certain distance, and at that distance there will be another borehole, and then the elevation data will be plotted like this, and then all of these will form a uh, a layer like that throughout. We'll just extrapolate it to form a layer. Okay, so for this particular, I can just minimum for x-axis. Okay, minimum for x-axis maybe we say 0. Okay, because this one is starting point, our starting point, and this one we will call it 0. This will be 22 meter, and this is going to be 30 meter, so 52. So 55 would be enough. So what we're going to plot is still is 55 meters. So 0 is the minimum, and the maximum would be 55. Okay, so we'll keep it like 55. Okay, very good. Okay, you see as we click it, this particular appears. Very good. Now we have to do it further. Okay, so if you here one thing you have to understand, if this is right now positive, if we do it positive, it will be like this. Okay, it will go upwards. I want to do it negative. So minimum is 0, then negative, we're gonna do it the maximum. For this particular, it appears, let's go down and see the maximum is, so 9 will be the maximum. Fine. For, so I will just keep it minus 9. Okay. Okay, sorry, the maximum is 0 because we are putting it minus 9. So we put minus 9 here, and then yes, this automatically adjusts and it's nicely put. Okay, very good. This is the distance and this is elevation. Furthermore, if you want the increment to change, so we just check this box, uncheck this box, and we can change the increments. So this one is at 555. If you want to change it, we can do it that as well. But I think this is fine for me. And for this one also, it's fine. Because you should be able to see it properly as well. If you put a lot of points, it will be like it won't be visible good enough. So it's auto is fine. Okay. So as we now we have axes, what we need more is the points. Okay. So what we can do is we have to create some sketch. You go to the sketch and then you have to uh, if you want to draw here, you have to go to the draw and then draw some points here. So that can be used later as a reference to create regions. Okay, so we click on the points, and the first point that we need here, you know, draw a point. So we just put a point here, okay, and it's at 0, 0. Okay, okay, very good. So so we gonna put point only. We don't need number. So there is number appears at the point. We don't need that. So we want only the point. Okay, very good. And then another point. Where is another point? This one is at point 5. Okay, point 5. So we go here somewhere. Just put it like that. Now, you see this one can be adjusted. Why? It's 0.5. Okay, we adjust it and then it quickly changes to. You can just roll your mouse button and then just zoom it. Very good. So we just created another point for this. Then later another point is at 1.5. Okay. Okay. So we create another point at somewhere. We just click it and then we decode it. So y is 1.5. Okay, cool, very good. Now we need third point. Where is the third point? Third point is at somewhere around 2.1. Okay, this is the 0.5, 1.5, 2.1. Okay, so now 2.1. So I just click somewhere here. Okay, and then we can make it, change it, and then do the step there. Okay, very good. Then fifth point is where that's here. So it's around 5.5. Okay, very good. So we just go somewhere here. Okay, and right now you see the snip to the grid is on. That's why it's slipping to grid. Okay, and slipping at 1 meter. If you can reduce it, the snip will be at this. It's reduced. If you reduce it more, it will be smaller. The grids will be smaller. It's I don't know if it's properly visible. The grids will be smaller like this. Okay, I think the one is fine. Anyway, we can edit it, so that's why no problem. Okay, so where it was at 5.5. Okay, very good. So we put it this one. We put it at 5.5. Okay, we got another point as well. Now the second last point is around 6.5. So 6.5 we put at somewhere here, and it will be 6.5. Okay, very good. And then the last point is at 7. Very good. Just put it at 7. Okay. So hope everything is clear till now. And this is how we plot the rest of the borehole as well. Okay. Another thing, I will just fast forward that process of plotting others, but we'll show you one. So now earlier it is at the 7. Okay. Borehole 1 was at 7. Now what we are going to do is now it is going to be 22. Okay. So the second borehole, the BS2, is going to be at 22. So 22, 0. Okay, 0, 22. So let's plot it. So somewhere I will plot it here. So it's saying x is 22 and y is 0. So that's where I want to plot it. Okay, and then another just where it is. It's around zero point 0.5 again. Okay, so we can just make it zero point 0.5 and then make the grid smaller and just it's here. Okay, it snaps to it, and still it is at 1. Okay, I want it to be at 0.5, so I can just delete it. Okay, no problem. We have to zoom it a little bit to make the zero point 0.5 grid visible. Okay, okay, very good. So we did it, and similarly we can finish it. So before that, I will just finish it, and then we will directly start drawing the region. Before that, I'm gonna show you another thing. We can actually put some text here also. So this one is BS1. So here, if you just click on here or sketch and go to the text, same icon you have here, you will be able to insert a text. So right now here, I just want to insert text, and when you are doing analysis, you can choose these particular options, but right now it's irrelevant. Okay, so let me just say BH1. Okay, and we can say somewhere there. BH1. Now it's asking for another location. It's still there, but if you have to change it like BH2, I can make it BS2 and then insert it here. So it's BS2. Okay. And similarly, the last point is where? Where is the last point? The last point is at 55. Uh, sorry, 52. 52. Okay. So we can add that at 52. Borehole 3, solid borehole 3, and insert somewhere here. Okay. So we have all borehole level. And now I will plot quickly, and then we'll show you further process. So now that we have successfully created, plotted all the points here, and I haven't yet plotted the point for the groundwater table. We can do it later. Okay. So now let's create a region. Let's start creating region for each of the layers. Okay. So go to again to the draw. Okay. And then we can click on the region, and then in here it will automatically snap to those points. Okay. Huh? So that's good. So we start with it should be closed. The region should be closed. Okay. And it's right now polygonal. Okay. So it's a domain region, not floating region. Next to it's a domain region. And click on here. Okay. And then here. And then here. And then we come down to just create our first layer, this particular layer. Okay. Then here you see how it snaps. Okay. So it snaps to the point. Lock perfectly. Snap here. And then close it the region. And as it is closed, it will be hashed like this. Okay. And even the region number is being shown. Okay. You can hide it later. I will show you how to do that. Okay. Similarly, we can create other regions as well. Okay. So I will just fast forward, pause the video, and just create all other regions. Okay. And so now that we have drawn all the regions, I'll just close this particular. Okay. And you see right now, each region is it looks kind of same. Here you can see the numbers for each region, but I want it to better appear. For each region there must be certain legend. So it must be in different color. So for that, what I'm going to do is define the materials. Okay, so I'm going to define here, go to there and add materials. So add it and add materials. So this particular color, I can just change this and name it as here in our borehole log. Here I see it's first one is sandy loam. So we'll just go ahead and put it as sandy loam. Okay, sandy loam. Okay, and we'll keep this color. Okay, let's keep this color. Okay, so you see this one is changed. Now again I add new material, and this time we call it another one sand here, and you see here is sand, again here is sand. Okay, and it is classified as same. Okay, however there is a small difference, but this is classified as the same. So we'll keep it like that, and we'll just put it as sand. Okay, and I will keep the default color, or you can change it, and okay, just keep it like that, and we'll show you what happens. Okay, so we have added sand as well. Add new one. Okay, now add new one is this one is silty sand. Okay, so we call it silty sand. Okay, I want it make a bit distinguished, so change the color to this particular. Okay, okay, and then add another one, another material that we have here after silty sand. This one is again sand, clay sand. Okay, so clay sand. Okay, keep it as capital. And we'll change the color, maybe make it like this. Okay, and then again we add another, we have more layer here, sandstone layer. Okay, it will be better if we add the same color and hatches, but for right now I just keep it this for the purpose of this tutorial. I'm just putting it random. Okay, So this one is what? Sandstone. Okay, sandstone stone. Okay, and the color maybe I make it into something like blue. Okay, make it just distinguish. Okay, like this. Very good. So now we have all the colors defined clearly. Another thing that we have to do is we have to assign these colors, okay, to each region. Okay, so we have to put this. So now we have to assign, the materials to each of our region. Okay, so very good. Here we have that option like called draw materials. You click on it, and then there is a pop-up, and how we gonna assign it the region. Okay, so first we have to select which one we want to assign, and then click on the region where we have to assign. So we check our borehole log. The first one is sandy loam. Okay, so we select first sandy loam from the drop down sandy loam. Okay, very good. And then we click inside. Make sure you click inside uh, the particular region. Okay, and you can see if it has been assigned or not. You view assign, and this has been assigned. You see the color right now here is, but it's not displaying here. Okay, so we'll solve this issue in one go. So close it, and why I will show you. And the second one, second layer is of the sand, just sand. Okay, so we select from the drop down the sand, and then just click on sand. If you remember, our third layer is fourth layer is also sand. So I can just put the sand to the fourth layer as well. Okay, very good. Now the third layer here is silty sand. Okay, so before doing that, let me quickly solve that issue so that it's visible, the colors are visible, and it's less confusing. Okay, so we just close this definition box and then go to our define and the materials, and we click on the clay, any all of these, and then we assign the material model here. So no material model has been assigned, so that's why the colors are visible. So I will, for this instance, I will just choose the default, the first one, more column. Okay, good. Clay is sand is defined. Then again for sand, for each of these, I will do the same. Okay, and you see now the colors is visible. Colors is you can see the color and sandy loam, more color, and you see color is getting visible. Then the sand. Okay, so all has been defined. Okay, so we close this. And here, you have option to show legends. So I just click on it, and the legends will be shown. Okay, so legends is shown here right now. Here we already have assigned two type of materials. We can actually drag this somewhere here. So we go to the modify tab, this one, and then we just drag it. You can move selection and how much you can define, or you can just grab it and drag it over here. It's good like this, something like this. Okay, and just keep it there. Now we assign the remaining areas. Okay, so for that again I go to this option, click on it, and then what was our third layer? You just check it. Third layer was silty sand. Okay, so select the silty sand. Okay, and assign it. Okay, you see the legend has been also updated and the colors are visible. Very good. Then after that, after this particular sand, we have clay sand here. So we assign, select the clay sand from the top and assign the region. Okay, very good. And then the last one is sandstone. Okay, so there's a thin sandstone layer at the bottom. Okay, so you click on it and the sandstone has been, so you see everything is there, and it looks quite good, you know. And the location of boreholes are also shown at 22 meters from the first borehole is second, and 30 meters from the borehole second is our third borehole. Okay, so these are just looking beautiful. And we can change a little bit of things also. You see, these are visible right now. We can go at this place and then regions. We can even, the lines that were separating this region, we can hide them. These are lines. We can just hide them and make it more beautiful. Okay, and then even we can hide the numbers. These points, we can hide it, and it looks much better. And this one was for the numbers of for the region, and we hide it, and this looks particularly more beautiful. Uh, so this is the way we can visually represent our file layers from borehole data log, and it's a good. Similarly, you can like for just for that particular uh, the water, you can also create a line, and that will be able to represent, and you can even adjust thicknesses of the line. You can explore a little bit more. This is just I thought this tutorial is not available online, so I just made it so that it's the visual representation for the file layers from the whole is um, captured in this tutorial. So thanks a lot for watching this guys. And like, share, subscribe to our channel. That's all. Have a great time. Thanks.